We're looking at set notation, and we're focusing on unions and intersections. So set notation is a set of ways of writing information about sets of numbers, letters, or other objects. So a set is just a collection of numbers or letters or other objects. The sample space we mentioned before, that is the set of all possible elements. Each number or letter in a set is an element. So in a particular situation, the sample space is all the possible elements in that set. So it's also called the universal set. Now, we discussed the sample space before. That same definition holds. We're just transferring this to set notation. As I said, there's a few letters that we can use to represent the sample space. It could be S. It could be omega. We could use U for the universal set. I think there's one about xi. I have no idea how to write it. So you can. There's a whole bunch of different standards. I'm happy with S. The null set is an empty set. That is a set with no elements. So if I said that one set was all the odd numbers and one set was all the even numbers, the set that was both would be null. There would be nothing because there's no numbers that are both odd and even. We represent the null set either by an empty set of curly brackets or an O with a strike through it. Now, I was just talking about the overlap of two sets. The intersection is all the elements in the set which belong to two different groups. So we'll do an example very shortly. I'll have two sets of numbers out of a larger set. In fact, I'm going to scoot down. What we'll do is my universal set is the first 10 integers, that is numbers 1 through 10. I guess it's the first 9 integers. No, it's not. So this universal set is the first 10 integers. And I've got set A and set B out of that. And if you're being very clever, you'll see that set A is the prime numbers and set B is the odd numbers. So that's why 10 was missing. It's neither prime nor odd. So when I look at the intersection of two sets, it's which numbers are in both set A and set B. So the intersection is the elements in both A and B, and the notation for that is A. Now this just means the intersection of A and B. I know it looks like A and B, like rock and roll or R&B or whatever, and that's a good way of remembering it, but it's not actually an N. It is an upside down curve. It means the intersection, and that would be how you'd remember it. A and B is a good way of remembering it. That's everything that's in both at once. The union are elements that are either in A or B or both. Both. And the notation for that is A and an upwards curve B. This means the union of A and B, and it does look like a U for union, and I like to sort of read that as or. You can imagine it being pronounced A or B if you spelt that out, maybe. So if we are illustrating that, and I'll just move down a bit to these little Venn diagrams, they're very useful for representing what's in which set, what's in the overlap, the intersection. So this region here would be the intersection, A and B. Anything that's in A or in B or in both, and I've definitely coloured in that both section there, that's the union, A or B. So move that up a little bit there. So the intersection is only where they overlap. The union is anything that's in A or B or both. Now we can have other things going on in there, of course. We can have just the elements in A. We could have the elements, I'm just picking exciting colours here. We could have only the elements that are not in A. So I'm very carefully shading in everything except what's in A. Now that is A with the apostrophe after it that you'll remember was our complement of A, saying not A. And we could also have the combination of some things happening. So not A and not B would be, we're looking at everything that is not in A and not in B. So there's various different combinations that we can have, and representing those sets, so the set of things that is not in A and not in B, it's very useful to do that with a Venn diagram. We can also do that with a two-way table. I'll see if I get to that this lesson. So mutually exclusive events have no elements in common. So remember, the set of odd numbers and even numbers, the sets thereof, are mutually exclusive because there's no numbers that are both odd and even. So that means that their intersection is a null set. There's no numbers in that intersection. The complement, remember, is the event not happening or not in that set. So the complement of A is not A. We illustrated those there. And do remember that the probability of A equals 1 minus the probability of not A. This notation here, an N out the front instead of probability, means the number of elements in set A. And the same rule holds. The number in A is equal to 1. No, it's not. That would have been very foolish of me. Don't listen to me. So, some wording that you might like. That's also in the key ideas box on page 510 and 511 if you need to explore that a little further. So for example, as I said, we have the first 10 integers here. The set A is the prime numbers, the set B is the odd numbers, and there are some that are in both sets, such as 3, 5, and 7. So that is the intersection of set A and B. And what we'll often be asked to do is to put the elements themselves into a Venn diagram where we've got set A and set B, and where the overlap is, those elements themselves go in the intersection. Everything left over that was in set A is 2. Everything left over that's in set B but not in set A goes in here. And I told you this was the first 10 integers, so 10 goes out here because it's in the universal set, but it's not in either set A or set B. If I got asked to list the sets, the set A and B is the intersection of A and B, so that set would be 3, 5, 7. If I got asked to list the union of A and B, that set would be 1, 2, 3, 5, 7, 9. That's everything that's in A or B. And I could have listed all sorts of sets, A but not B, and things like that. In fact, let's do that one. A and not B. Have a look at it. It has to be in set A and not be in B, so that set is, that's our little number 2 right there. If you got asked for the probability that a randomly chosen number was in set A, you'd count the number in set A, that would be, and let's actually just write that. That would be the number in set A over the number in the sample space. So see how this notation gets a lot simpler. There's 4 in set A, there were 10 in the sample space. We simplify that to 2 over 5. If I asked for the probability that a randomly chosen number was in A or B, that would be the number in A or B divided by the number in the sample space. There's 9 elements in A or B, the union. There's 10 elements in the sample space. Just double checking, if we got asked if the events or the sets were mutually exclusive, they're not because there's some overlap. And we'll leave Venn diagrams and two-way tables till a little later.